Today we are going to see another interesting topic which is called SSH certifications. Uh, we need there is this concept called SSH certificate, and we're going to see a proper implementation on how to implement this SSH certificate. Um, and this will be less of a primer than more of an how to use SSH certificate and how do you implement SSH certificate, rather than me explaining why SSH certificate is better than key based certification and etc. So why did I started to dwell into this topic? The main reason is now I have around two Raspberry Pis, and then four instance, and then a bunch of small instance running around, and then now I've reached a point where I need to manage all these certifications to SSH into them. Else, if I just use the key based SSH, then it gets a little difficult, especially one managing them, to giving out principles to each instance. 3. The most important thing is expiry. I want each certificate or each key to expire within a month, which is not possible through key based SSH. So that's why I went on a deep dive into certificate based SSH. So this will be an implementation of an certificate based SSH, especially this use case where I found few videos on the internet where they talk about having one single CA. What CA stands for is certificate authority, where they have one single CA and a bunch of users and bunch of machine. But that is not a very ideal situation in a bigger organization, because users can assume there is a compromise in the CA's private key. Then what happens is both users users key needs to be replaced, as well as the machine's host keys needs to be replaced. So usually what a large organization prefers is to create a separate user CA for generating and certificates for users, and then host CA for generating certificates for all the hosts. So in this example, what we're gonna see is we're gonna see creation of an user CA, host CA, and then a user wants to SSH into a Raspberry Pi. So our Raspberry Pi is the host here. I am a user, and then I just wanted to SSH into Raspberry Pi, and instead of using key based SSH, we are going to implement a proper certificate based SSH to SSH into Raspberry Pi. So how a basic overview before I'll jump into implementation is, so what we are going to do is we're gonna the basic idea behind SSH is SSH based authentication is trust. So we need to create trust between users and the host, so that trust in the sense trust as well as credibility, such that the connection between the user and the host is always encrypted and verified, such that there is nobody in the middle, that is a man in the middle, there is no man in the middle attack or any form of attack, and the connection remains always stable and then very safe between user and the Raspberry Pi. A larger organization does more than just direct SSH between user and the host. They have something called a bastion host, or they might have a jump server and those things, that is intermediate between the user and the Raspberry Pi, the host. But we are not going to look at all those things in this video. The main aim of this video is to just see how an user can SSH into Raspberry Pi using Raspberry Pi or any machine using SSH certificates. We have a host CA and then a user CA. Instead of that is the ideal way of doing. Instead of launching two different instances, what I'm doing is I'm just launching one single instance which will act as an CA, but it will generate user CA as well, user CA certification as well, host CA certificate as well. But the proper way to do is to separate the host CA and the user CA. So for that machine, I am booting up an EC2 instance in AWS. You can the steps are the same. I'm using the free tier, so I'm just because I don't have to do any intensive task here. Just I wanted to demonstrate the how the certificate authority works. Certificate authority can be anything, whatever you want. So there will be a machine which is very safe, maybe removed from the internet. Keep it very safe, and then it just needs to you just needs to go and then create the certificate. There shouldn't be any other use for that machine. So what I'm doing here is I'm just opening the port for just SSH purpose, and then basic 8 GB RAM and all the stuffs are really the same. So I am not adding a key pair here because I will be logging into the EC2 instance directly through our EC2 instance connect, which is a feature offered by AWS, where you can just directly SSH into the system through a web interface. So since I don't have any other use case other than just showing you the demo, I didn't create a key pair, and I'm directly SSHing into the instance. So you can see our CA instance is ready. So what the CA instance will do is it'll be the centermost point of the whole system, where it signs the certificate with the CA's private key. So and then it creates a trust between the CA users and the Raspberry Pi. So for that case, the first step which we need to do is create a key pair. That is, the certificate authority should have a key pair. Since we are doing both the host and user CA in the same machine, we need to create two different key pairs. That is, one key pair to just sign all the users certificates, and another key pair to sign all the host certificate. So what you can see, I am creating an user certificate here using the SSH keygen command, and after generate so here there are different algorithms through which we can generate this key. I am in few places I would use RSA, and few places I would use ED25519 and so on. That is completely our wish. So here you can see I just generated a key pair with a private key, and that is user underscore CA, and a public key, that is user underscore CA dot pub. So this is an RSA key, and always note that you shouldn't be sharing your private key, especially you should never share your private key, and especially in CA we should make sure that it is always safe and it is not compromised. So but this public key can be shared with anybody, because it's of no use, and that is the main purpose of creating a public key. Similarly, what I am doing is I will create another key pair, which is an host key pair. Say one private key for host CA, and one public key for host CA. So now we have two pairs, one for host CA and another for user CA. So this is the first step. Now what I am going to do is I will SSH into our Raspberry Pi, which is our host. So from I have an key based SSH access to the Raspberry Pi. That's why I'm able to SSH here. But if you don't have any access, somehow enter the Raspberry Pi and you need to set things up. So first what I am doing is these are the older keys which I have before, and which I use it for some other purpose. But here for this example, our host needs to generate its own private and public key. You can see I have already generated an ED25519 key as well as an RSA key. I am thinking of using the RSA key which I generated before for this experiment. you can notice that ED25519 key is smaller than RSA key, and in recent days I noticed that ED25519, the elliptical algorithm is far more preferable than an RSA algorithm. But but here what I'm doing is the host needs to have an key pair as well. So I am looking at this public key which I created for the host. So what we eventually want to do is our host a private key needs to sign with our host public key. So for this, what I am doing is either you can SCP into this, you can SCP into our CA instance, or just send your public key to your CA instance, and then using the private key of the CA and public key of the host, we will be creating our host certificate. Same command SSH keygen, and then what I am doing is I am giving 1 week duration for the key, as well as I am just giving one principal for it. So finally, after running that command, after signing with the private key of the CA, I have generated a certificate here, which I can just transfer it to our host machine. You can see here, this is the certificate that has been finally generated by the certificate authority for the host. This is very necessary because host needs to verify, host needs to be legit, as well as the user needs to be legit, and the CA is the centermost guy who verifies the legitimacy of host and the user. So now we have set up the certificate for the host CA. The next thing what I am trying to do here is we need to make sure that our host needs to know who is the trusted CA here, because SSH works on the basis of trust, and then we need to make sure that the host knows who's the CA. That's why I'm mentioning the host certificate here. At the same time, we should also mention the user's CA's public key here as well. So every time you change some config, you need to do one system CTL restart to restart our SSH server. That is a very common mistake which I do often. Now I am going to repeat the almost same process with the user. Now using the there is an this is the public key which we are creating for the host CA. So what I am trying to do is I am trying to make sure that I notify the instance that this is the certificate which has been used to create the certificate for you. So the star here means I am allowing everything here. You can just boil it down to one domain or just an URL, IP, whatever you want. If you look at the unknown host, I have added the host certificate authorities public key as well here. Next we'll go and this is my user server. I have to repeat the same process. That is, I'm using the key which I already created with and what I'm going to do is I'm going to get myself the user signed with the user CA's private key. This user CA and host CA, it is encouraged to keep it in different machine, but for this example I have kept both the keys in the same machine. You can, I just copy pasted the public key here. Either you can copy paste the user's public key directly, or you can SCP into our certificate authority. So now we have the public key of the user as well as the private key of the host user CA. So using the private key of the user CA and the public key of our user, we are going to create a new certificate for the users. While creating the certificate, this is the main advantage of creating certificate than using key based authentication. You can see that we are fixing a lot more parameters here, like plus 30d, which is valid for 30 days, and then minus and void is the name of the principal. That means he has to be an user void to use the certificate. We get all these flexibility when we use a key based certificate based authentication. So now what I'm trying to do is I'm trying to create the certificate here, and then once the certificate is created, we can just transfer the certificate to the user. Now both the user has a certificate and then signed by an user CA, and then a host has a certificate in his host system. Host in the sense here Raspberry Pi in a system signed by a host CA. Instead of doing SCP, I am just creating the copy pasted the file, and then I will create the certificate here. This is some used certificate which is there, which I am clearing off, and then I will just paste it here and then create a new certificate. In the end, certificate is just a file with a bunch of text, so you can just remove an old file and then paste the new content. It will become a new certificate. This is the user certificates public key. We need to exactly do the same which we did for host. This is very essential because we need a way to verify that the CA is legitimate, and there is no attack in the middle calling themselves as a CA. By storing the CA's public key, we will always be sure that the legit CA has been signing the certificate and there is no breach in the middle. And then I am trying to modify the config file by adding the trusted user. So here I have added the trusted user's CA key, that is the CS public key, as well as the host certificate. Exactly, I'm doing the same thing which I did for the host here by adding the certificate authority and the key of the certificate authority. You can see I have added the host CA's public key here. Finally, you need to just mention where our private key is there and then the certificate file which has been sent to us by the certificate authority. The reason for adding a host CA's key, public key, is to just identify that who are the hosts that we want to SSH. This is an additional way of doing it. Now we can just directly write SSH and then the name whatever we give near host, that is 192.168.0 or 112, it will directly SSH. Or we can do our good old way of writing our whole SSH syntax and then SSH into it. Now there is, you can see that I just ran the whole syntax here and it just directly went and SSH into the system.